Hello everyone, you are welcome to this class. So in this class, we want to continue from where we stopped on trigonometric ratios. In our last class, we discussed trigonometric ratios of special angles. Today, in this video, we want to look at trigonometric ratios of angles between 0 degrees and 360 degrees. Now, the purpose of this is very simple. Whereas if you look at a four-figure table, you notice that the angles we have in four-figure tables ranges from, when we come to sine, cosine, and tangent, you notice that we have from 0 to 99 degrees. So anything above that, 90 degrees rather. So anything above that, so we'll not have, will not be able to check it. So when you have angles that is above 90 degrees and there's above 90 degrees, how are you going to check it on a four-figure table? Except you are allowed to use calculator. So there are some examinations that requires you not to use calculator. Just recently that we have examining bodies that are now allowing students to use calculator in some exams like JAM. Unlike before, you can't use calculator to solve questions in JAM. And then even in WIEC, you cannot use any kind of special calculator. So that is the essence of this topic. So you have to pay attention to details in this video, so that you get benefit out of this. I hope that is very clear. So when we talk about trigonometric ratios of angles between zeros and 90 degrees, we have to go back to plane, Cartesian plane. So we go back to Cartesian plane. So let's start with it and see how it goes. All right. So on a Cartesian plane, we have this. So we have this grid. This is y-axis, and this is what x-axis. So on this plane, so at this side here, all these sides are positive. So anything that falls here is positive. Anything that falls under the x-axis, here, so this is 1, 2, 3, 4, 5, and this will be -1, -2, -3, -4. Then on the y-axis, so this is the origin 0. Above the origin we have positive. Above the origin. This is 1, 2, 3, 4, and below the origin we have negative. All right. Now, so this is where we are going. We are not plotting any graph, but we want to use this so that you understand the concepts clearly. As you can see, this plane is divided into 4 quadrants. It's divided into how many quadrants? 4 quadrants. So the first quadrant is from here and is moving anti-clockwise. It's moving what? Anti-clockwise. So the first quadrant is here. This is the first quadrant. This is first quadrant. This is first quadrant, and this is a second quadrant. So the second quadrant is there. All right. Why the third quadrant is here? And this is the fourth one. This is the fourth quadrant here. All right. So this is fourth quadrant. Now, so what we want to achieve here is, trigonometric ratios are sine, cosine, and tangents. All right. That is so catois. All right. Now, at the first quadrant, which is from here, from this place to this place, this is 0 degrees. While at the top here, at this place will be what? 90 degrees. Then from here, when you move down, this will be what? 180 degrees. And here will be what? 270 degrees. While this will be what? 360 degrees. All right. So in the first quadrant, if we look at it vividly, we're still going to look at it one by one. We're going to look at the quadrant one by one. Now, the one thing I want to take note here is that here we have all the ratios to be positive. All the ratios are what? Positive here. All right, that is all. Then for the second quadrant, only sign is positive. Only sign is what? Positive. While the rest are negative. That is, cosine will be negative and tangent will be what? Negative. In the third quadrant, the tan is positive. Only tan that is positive, while the rest are negative. While in the fourth quadrant, only what? Cos. Only cos that is what? Positive, while others are what? Negative. I hope that is very clear to you. Now, I'll not be taking them one after the other and explain them in details. Why all are positive, why signs is only sign are positive in the second quadrant. If you look at it here, so anything that we have there, x and y are positive. So you can see from here, from 0 origin towards the right, x is positive. And from the origin upward, y is positive. Then if you come back to this place, to the second quadrant, y is positive, y x is what? Negative. Are with me? Then in the third quadrant, x is negative, y is also what? Negative. Then in the fourth quadrant, which is the last quadrant, x is positive and y is what? Negative. I hope this is very clear. So this is just the general overview of what we want to look at. We will now be taking them one after the other in order for us to explain it in details. And I see the beauty of this topic. It's all very simple. I just want you to pay attention to details here. So move to the next one. And here we're going to look at the first quadrant. So in the first quadrant, I'm going to draw this. So let me draw this here. Don't forget, I said this is 90 degrees. This is 0 degrees, right? And this is the first quadrant. First quadrant here, right? So in the first quadrant, so any angle you have here, for example, you have this. So this line is drawn. So we're now considering this angle to be theta. Then let's draw this line here, right? So this is going to form a right angle triangle, all right? So this is going to form a right angle triangle. So this is y. This is y here, which is positive. So the same thing, y also, this is y also positive. I hope I'm making sense. And also here, x is what? Is also positive. Then this hypotenuse here, it is going to be what? 1 unit. Now, if we want to find, so it is, you notice that under the first quadrant, so 0 is less than theta. This is the theta we have here. 0 is less than the theta. Then this theta is less than what? 90 degrees. Because the theta we are looking at is not up to 90 degrees. But 0 is less than theta. Then theta is less than 90 degrees. That's the condition there. Then after that, we want to find the sine, cosine, and the tangent. Now, sine, if you have sine theta now, sine theta, which means opposite over hypotenuse. The opposite is y, which is plus y, all over hypotenuse, which is 1. So you can see that this will also give us what? Positive. I hope I'm making sense. It's going to give us what? Positive. So that means sine is what? Positive. That will be sine theta is positive. Then we go to cos. Cos theta. Cos theta. So cos theta, which is k, which is adjacent. So this is the opposite here. This is the opposite. This is adjacent. This is hypotenuse. So that is k. That is x plus x. This is going to give us plus x. All right. All over 1. So this is also positive. Plus cos theta. I hope I'm making sense. Then we check for tan as well. For tan theta, which is twa, opposite over hypotenuse, which is x plus x, plus y rather. The opposite is plus y, and the adjacent is what? Plus what? Plus x. This is also what? Positive. Plus tan what? Tan theta. That's the reason why in the first quadrant, all the ratios are positive. So what does that mean? If you have a theta that is less than 90 degrees. Let's give an example. For example, so you have sine 45 degrees. So this 45 degrees is less than 90 degrees. So this means 45 falls under the first quadrant. So it falls under the first quadrant. That means that you just check it on your fourth figure table. And you can get 45 degrees on the fourth figure table. And if you can't get it, you can go to your calculator and get sine 45 degrees. All right? So once you get sine 45 degrees, so which will give you 0.7 0.7001 rather. So I hope that is very clear. So that is that on that one. So the same thing, if you look at cos angles that is less than 90 degrees, it's still the same thing. I hope this is very clear. So we move to the second quadrant and see how the signs, the chord is positive while others are negative. Don't forget I said in the second quadrant is only sign that is positive while others are what? Negative. So let's see how that one goes. So the same thing will be done here. We have the quadrants done. So this is the second quadrant, Right? So here we're going to have an angle that goes this way. We have an angle that goes this way. So in this case, we're going to have another line here. So let's have a line here, a line that comes here. So we are considering this angle here. And from here to this place is where the theta is. That is where the theta is. So which means you can see from here to this place is 180 degrees. That's angles on a straight line. So meaning that this angle here, the angle we have there will be 180 degrees minus what? Minus theta. We just remove theta from 180, so we're going to get this small acute angle here because we are trying to get acute angles, right? So, and this quadrant is telling us that 90 degrees is less than theta. 90 degrees what? Is less than theta, and theta is less than what? 180 degrees. So let's now check for sine theta. So when we have sine theta, so don't forget, let's label this is at this place y is positive and x is what? Negative. So this is going to be the opposite. This is theta, this is opposite. This is hypotenuse, which is 1, and this is what? The adjacent. So let's now look at sine theta. For sine theta, so that is opposite over hypotenuse. That is plus y all over what? 1. So that means sine is positive. So it then was sine. So what is the theta here? That's going to be 180 degrees minus what? Minus theta. That is the reason why sine is positive in the second quadrant. Now, so let's now look at cos theta. Cos theta. So cos theta, which is what? Adjacent over hypotenuse. Adjacent is minus x, is negative. All right, that is minus x divided by 1. So that is, this is minus what? Minus cos theta minus cos 180 degrees minus what? Theta. I hope I'm making sense. Then for tan as well, for tan, so which is what? Twa. So twa, which is opposite, which is plus y, all over the adjacent, which is minus x. So you can see this is negative. This is going to give us what? Negative. So in this case, this will be negative tan 180 minus theta. So you can see the reason why this is positive and this is negative. Now let's now look at its application. Let's look at example. So let's look at example here. So for example, so we have let's say we have sine, first one, sine 140 degrees. So the first thing that will come to your mind is 140 is more than 90 degrees. So we can't get this on fourth figure table. So, and this 140 is less than 180. So this 140 falls under the second quadrant. So that means we're going to have it to be what? And because sine is positive in the second quadrant, it's going to be what? Sine 140 degrees, 180 degrees, which is this one, minus theta, which is 140, minus 140 degrees. So this will give us sine 40 what? 40 degrees. So sine 40 degrees will give us 0.6428, 0.6428. We check your calculator or fourth grade table. And at the same time, if you check your calculator and press sine 140 degrees, you are still going to get the same thing here. I hope you are with me. You are still going to get the same thing. Then for the second one, so let's look at cos 158 degrees. Cos 158 degrees, all right, equals to, now in the second quadrant, because 158 degrees falls under the second quadrant because it's more than 90 degrees but less than 180. So, and it's less than, cos is negative, as you can see here. Cos is what? Negative. So you need to take note of all this. So that means it's going to be minus cos, then in bracket 180 minus what? 158 degrees. So that means this is going to give us minus cos. When you subtract it, you're going to have minus cos 22. And this is going to give us, so the minus here, then cos 22 degrees on your fourth grade table and your calculator, you're going to get 0.9272. And at the same time, if you press your calculator and punch cos 158 degrees, it's going to give you negative minus 0.9272 straight. So then for the third example that we're going to look at under this one is tan, let's say we have tan 123 degrees. So which will be negative as well, tan 180 minus 123 degrees, which is equal to minus tan 57 degrees. So which will be minus 1.5399. I hope that is very clear. So that is the second quadrant. Then move to the third quadrant. In the third quadrant, if you come back to this place, in the third quadrant, only tan that is positive, sine and cosine are what? Negative. All right. So let's look at how that one goes now. All right. In the this is third quadrant. We have third. So let me use the red pen. Third quadrant. So we have this. All right. So in the third quadrant, we have, this is the first one, second one, third one. So we're going to have a line that goes this way. So that means from here to this place is the theta, right? And we are moving from 0 to this place. So we need to find this angle here. So this angle is what we are looking for. So that means you notice that the angle, the whole angle is greater than, so that means in this quadrant, 180, all right, in this quadrant is less than theta, and theta is less than 270 degrees. That is the third quadrant. Now we are looking for this is angle 90 degrees. So that means that theta minus 180 degrees, because we want to remove 180 degrees from theta, because the theta is from here to this place. So we then remove this part, this shaded part. We're going to have this place left. That means the whole theta, which is from here to this place, minus this shaded part, which is 180. That is that. So this is the opposite, and that is why it is negative. Y is negative here, and x is also what? Negative here. I hope this is very clear. So let's now look at sine. So at this place, so we're going to have sine theta will be equal to opposite This is adjacent, this is hypotenuse, this is 1. So opposite, which is minus y, all over 1. So that means sine is negative here. Sine is what? Negative. And we have said that. So that is a proof. That is minus sine into bracket theta minus 180 degrees. Then we go again to cos theta, which is equals to adjacent over hypotenuse. What is the adjacent? X minus x over hypotenuse. That means cos is also what? Negative here. That is what? Theta minus what? 180 degrees. Then we go to the next one, which is tan. So tan theta, which is toa, opposite, which is minus y, over adjacent, which is all minus x. So this will give us plus. So that means tan is positive. Tan theta equals to theta minus what? Minus 180 degrees. I hope this is very clear. So that is all the proof. So if we now have question by this, we have, let's say we have sine 120. Sorry, this is more than, should be more than 180. That's, let's say 210 degrees. So that means that since sine is negative in the third quadrant, it's going to be minus sine into 210 is the theta minus 180 degrees. So this will give us to be what? Minus sine minus, that is going to be minus 30, that is 30 degrees, which is going to give us minus 0.45. Then for cos, let's have another, let's say cos 192 degrees. So cos is also negative, that's going to be what? Minus cos 192 minus 180 degrees. So which will give us minus cos 22, cos 12. So that's the answer we then give us minus. So we check calculator, you get was minus 0.9781. And so on and so forth. You can do the rest for tan as well. So the last quadrant that we have here is the fourth quadrant. So I'll still come back to this place. The fourth quadrant. So under the fourth quadrant, so let's have this fourth quadrant. In the fourth quadrant, we have this. So this is the fourth quadrant. All right, this is the fourth quadrant. So how do we do that? So you look at it. We are moving from here, from the origin, which is 0. We are moving to this place. So this is the theta. All right. Now we're looking for this remaining angle here. So what will that be? So that remaining angle there, so what will it be? That's what we want to look at. So in this case, we're going to have, let's draw this on perfectly. So we'll draw another line here. This is going to give us 90 degrees. So this will then be 360 degrees minus what? Minus theta. So and mind you, y is negative here. X is what? Is positive, as you can see. So this is the opposite. This is the hypotenuse, and this is the adjacent. All right, with me, this is hypotenuse, and which is 1. All right. So we're not going to look at the. So here is only cos that is positive here, as I've told you here. So we've looked at that there. It's only cos that is positive here. So let's now look at the proof here. So under this one, that means we're going to have sine theta, which is opposite. And what is the opposite here? Minus y over 1. So that means sine is negative. That's sine 360 degrees minus what? Theta. Then for cos theta as well. So that is k adjacent, which is plus x. K adjacent plus x over hypotenuse, which is 1. You can see this is positive, cos 360 degree minus what? Theta. Then for toa, that is tan theta, which is going to be toa opposite, that's minus y, all over adjacent plus x. So this will also be what? Minus tan 360 degrees minus what? Theta. I hope this is very clear. So let's just look at one example under this one. Example under this one is this. So let's say we have tan 285. So this is greater than. So it falls under the fourth quadrant. So you always say, see the degree where the degree falls before you know which one are you going to. So it falls under the fourth quadrant. So in that case, this is tan. So and tan is negative here. So which means we're going to have it to be what? Minus tan into bracket 360 degrees minus 285 degrees. So which will be what? Minus tan. So when you subtract this, you're going to have 75 degrees. So that means minus 3.7321. I hope I'm making sense. So let's have this. So that is that on this video. I don't want the video to be too long, right? I don't want it to be too long. And then so now let's look at the shortcut for you to remember this so that you don't forget. Let's have this. You know, I said all ASTC. So that is the code I want to give you. This is ASTC. So let's write it from the beginning. That is ASTC. All right. Sometimes some people write it as they write it backwards. ACTS as in acts. Now, but I prefer ASTC. This might sound very nice when you're pronouncing it. So, but I'll give you the shortcut here. The A, I'll call it all. Then the S, I'll change it to students. Students. And the T, I'll change it to take. And the C, I'll change it to what? To coke. So I'll just say all students take coke. All students take coke. That will make it to remember. All means that all the ratios, let me show my face. All the ratios. That means that all the ratios are positive. That's all students. That is S, the first letter means sign, is positive. Then take, that means T, which is tan, is positive in the third quadrant. And coke, which is what? Cos in the fourth quadrant is what? Positive. I hope this is very clear. So that is just how to help you to remember it quickly so that you not forget. So all students take coke. All what? All students take what? Coke. So this is where we're going to stop in this video. I hope you find it very interesting and helpful. So what our advice is that try to watch the video as many times as possible for you to get the main gist, the main concept clearly. So because this is a new concept, when you are learning a new concept in mathematics, you need to pay attention. So you need to revise it, go through it again. You might not get it right at the first instance, but try to revise it. Watch it several times. That's the essence of this program. So we're going to meet in our next video. Bye for now.